Okay, Quincy the Quadratic, part 2. What does he look like? We've already figured out in part 1 where Quincy increases or decreases. Now we're going to take a look at what we investigated in the lab, which is called concavity. Is Quincy concave up or concave down? If you remember, a concave up function looks a little something like that, up like a cup. A concave down function will look a little something like this, down like a frown. In the case of a concave up function, our second derivative is positive. In the case of our concave down function, our second derivative is negative. Okay? So, as you might expect, our first step will be to find out what the second derivative is. If you remember in the first part of Quincy the Quadratic, we found out that f prime was equal to negative 6x plus 6. Therefore, f double prime is equal to negative 6, which will give us a little bit of an issue in part 2 where we need to find whether the second derivative is equal to 0 or does not exist. These are critical points of the first derivative. You'll notice there are no such points because negative 6 is always what that second derivative is equal to. This actually makes our lives pretty easy because when we go to do our sign test, there are no critical values and the second derivative is always negative, which means the function always looks down like a frown. Like if we were to have water in a cup and poured it over, we would have a concave down function. Since f prime is less than 0, always f is concave down on the interval negative infinity to infinity.